This is the last part for the Chapter 3 review test, Part 3, and we're picking up at number 15, which says find all the real zeros. So when you have something that looks like this, sometimes, like we'll see in number 16, you can do a factor by grouping and kind of cut this down a little bit. But this one doesn't look like that we're going to be able to do any factor by grouping. So what we're going to have to do is use the possible rational roots that we get from the rational root theorem, which would be factors of 6 divided 1 by the factors of 1, so 1 and 6, or 2 and 3, and then start synthetically dividing until we find at least one factor. Of course, that's pretty time consuming, so we're going to go into here and say we're going to change this 1x cubed plus 6x, no, not 6x, plus 12x squared plus 35x minus 6, and we'll hit graph, and we'll see if we can find one real root. It looks like we have maybe 1 at the 0, 1, 2, we don't have a 0, 1, 2, 3, 4, 5. Well, it looks like maybe the 6 is the winner, so we're going to go over here and see if negative 6 is indeed a 0. It is, so that's good news. And so that means if I synthetically divide by a negative 6, I'll be able to get out a factor, so that x plus 6 is indeed a factor. So 1, 12, 35, negative 6. I don't have any zeros, so I don't have any skips. Drop the 1, multiply. I get a negative 6, add down. Multiply, negative 36, add down. Multiply. We have ourselves a winner. And so my divisor times my quotient is a factored form of p of x, so this is going to be x plus 6 times the quantity. This is your remainder, your constant, your coefficient of x, your coefficient of x squared. So x squared plus 6x minus 1. Of course, there are no factors of 1 that when you subtract them you get a 6, so that means we're going to have to break out the quadratic formula. One of my roots is that negative 6. And we know, since this is going to come in a conjugate pair, that this is not a repeater, right? So this can't have a little square up top there or be times 3, because it kind of looks like it's a 2, but I think it just barely makes it through. So what we're gonna have to go through this this guy over here. And then we'll maybe blow into that a little bit so that you can see it kind of loops around. X equals a negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And so we get a negative 6 plus or minus the square root of, this is going to turn out to be a 40 over 2. It doesn't say it around. So we're going to say that these are my two, negative 6 plus the square root of 40 over 2, and negative 6 minus the square root of 40 over 2. You can also simplify the 40 to a 2 radical 10. But if we zoom in, let's see if we can zoom in over on this, you can see that this is where our other one will be popping up. That's still not so great. Let's try it again. Oh, see, it just barely cuts through. So a little bit smaller than the 6. So the negative 6 minus the radical 40, all that divided by 2, that's this part right here. And then here's the 6. And then the one that kind of looked like a 0, that's the one that's a little bit over with this. So that would be the negative 6 plus the radical 40 over the 2. And so we have, I'll split them up, negative 6 plus radical 40 over 2, and negative 6 minus the radical 40 over 2. If this upsets you and you want to round to the 100th, that's fine with me too. Factor the polynomial, that's a good sign. When it says factor, that usually means that you can kind of get around using the quadratic formula. Factor the polynomial completely and find all of its zeros. So this is one that you say, oh look, if I go like this, I can factor in out an x squared from the first one, and a 25 from the second one. And then these guys are both x plus 1, and so I get x squared plus 25 times x plus 1. So I could do a factor by grouping. So here's one. If I set each of these equal to 0, I got x squared plus 25 is equal to 0, and x plus 1 is equal to 0. So one of those is the negative 1. Now, when you try to take the square root of a negative 25, that doesn't work. But if you think about taking the square root, I'm going to go this way since I'm out of room, I get the square root, the positive or negative version of a negative 25. And if you rip his eye out, right, you'll have I times the square root of 25, which is 5. And so my roots are going to be 5i, negative 5i, and negative 1. Now, if you didn't see that factor from grouping, what you would have to do is go into here, graph it, and use your cheat. I'm going to have to zoom. Ooh, something. I made it angry. Let's see. X cubed plus x squared plus 25. Check. I'll fix my zoom as soon as it stops. And you'll see the one of these goes through, right? So you'll see that negative 1 works in your chart. But you won't see, obviously, the imaginary, right? So you can synthetically divide by the negative 1 and then get this. And then if you're not sure if you can take the square root of the negative, you can use a quadratic formula on the x squared plus 25, and your b would be a 0. A would be 1, c would be 25. Find the polynomial degree 3 with coefficients, integer coefficients, and I have a 0 of a 3 and a 3i, and so we know from the complex conjugate root theorem that if I have a 3i, I also have a negative 3i. And so those are going to be my 3 roots since I talk about a degree 3. So x equals 3, x equals 3i, x equals a negative 3i, and that came from x minus 3 equal to 0, x minus 3i equal to 0, and x plus 3i equal to 0. I'm leaving out my zeros because I'm running out of room, so I'm going to stick these guys together through multiplication. And when I distribute, I'll get p of x. Now you can start with any of them, but since I know that these back two are conjugate pairs, like we saw with the x plus 5, x minus 5, I'll distribute those first. And I'll get x times x, which is x squared. And a positive 3ix, and now the negative 3ix, and then I get a negative 9i squared. Now these are going to add out, and then I squared, remember, is really a negative 1. So when you see I squareds on things, it's really just going to flip that sign. So this becomes x minus 3 times x squared plus 9. Think about what we just had with our 25, right? So x squared plus 9 equal to 0 would be an x squared equal to a negative 9. When you take that root, you get that 3i and that the negative 3i. Send the x through. Send the negative 3 through. Technically, we should write this in descending order. Well, I guess I will. I was going to say I'm running out of room, but that already happened, so I might as well keep going, right? And there we go. And that's my polynomial. 18, kind of a long one. Find the intercepts and asymptotes. X-intercepts is when y is equal to 0, or in this case, r of x. So I am going to, let's see, how I'm going to write this. I'm going to say a right here. Say 0 is equal to 4x minus 8 over x plus 8. And what happens is you cross multiply. So it's going to basically wipe out that denominator, and you get 0 is equal to a 4x minus 8. Add the 8 and divide by 4, and x equals 2. And so that's your x-intercept. I'm going to scoot him right next to this. To find my y-intercept, I'm going to let x be 0. That's going to make life really nice, right? Because I'll get 0 minus 8 over 0 plus 8. So a negative 1. Vertical asymptotes is when you take your denominator and you set it equal to 0. and solve. So this would be C. And I'll get x equals a -8. Horizontal, you look at the degrees of your numerator and your denominator. If your numerator degree is less than your denominator degree, it's automatically at y equals 0. If it's equal, like it is here, where they're both to the first power, it is at the quotient of the leading coefficients. So 4 divided by 1, or a 4. And if you wanted to check, if you want to check to make sure that you have this in the right way, we can go to our y equals, put my numerator in parentheses, put my denominator in parentheses, hit graph, make sure this works. I think my zoom might be, let's do zoom fit. See what we come up with. And so do I have a vertical at a -8? I do. It's going to be really hard to see the y equals a -4 on this because of the way the window is. I can change my window a little bit. I probably don't need a y min of 300. That might be pushing it a little bit, so we'll get rid of that. And I certainly don't need a y max of 300. But let's do this x max of 1 so that we can kind of shift the graph a little bit. There we go. So there's the x equals 8. It's a little hard to see the 1. You're not going to see the horizontal, but you'll be able to see through here that if you go up forever, you just, oh, I'm sorry, not the 1, the 4. You're never going to get past that 4. And then you could also see the intercepts. Number 19 says the slant, which is our third case, where your numerator degree is higher than your denominator degree, in which case you'll have to do the synthetic division. And ignore the remainder. Take this is your constant, and that's your term, that's your coefficient of x, and that quotient, when you ignore the denominator, the remainder, is going to be your slant asymptote. Last question, we'll just make it. Use transformations to talk about this graph. Well, 1 over x looks like this, where I have asymptotes at y equals 0 and x equals 0. The negative is going to flip this guy upside down. And this is going to drag it 2 spots to the right. So I'm going to have an asymptote at the +2. And instead of being up here and up there, it will be flipped over. And this 3 makes it kind of get sucked in, I believe. And so we'll quickly sketch this. -3 over the x minus 2. I'll fix my zoom. -3 over the x minus 2. Oh, we didn't flip-flop. So we still have, I guess, my, oh yes, I have my y equals x. The other one is backwards. If it were positive, clear. 1 over x is the other way around. My fault. So that would be actually a negative. So 1 over x looks like this. And so this is going to go this way. And that is your Chapter 3 test.